Thank you. So I'm Laurent from Rakuten Institute of Technology in Paris. So as you may have seen in the previous talk, in RIT we do a lot of machine learning. And previously, and a long time ago, I started to use neural networks in 1990. So I'm very interested in how far machine learning and artificial intelligence can go, and what the limitations are and what types of limitation we have. Probably you've seen recently in the news very scary stories about artificial intelligence getting out of control. And these news are based on actual facts, for instance, about the chatbot Facebook AI worked on. But of course, there are a lot of misunderstanding about that. And many newspapers get rid of the bad picture. And so let's see why they do that. Everything comes from the idea of intelligence explosion, which was first mentioned in 1965 and used in the movie 2001 Space Odyssey, where a computer takes the control of a space station. And so we have a lot of science fiction story about artificial intelligence taking control of the world. You know all about them. But for some people, it seems to be very close, the close future, a threat for the near future. Probably you heard about Ray Kurzweil, who will talk about the singularity. The singularity is really very close to this idea of intelligence explosion. And the idea is that artificial intelligence progresses, and at some point it will reach the level of human intelligence and then outperform humans. And then there will be, the machine will be able to create new machines, and then the explosions comes from that singularity point. And super intelligence, Nick Bostrom talks about, is when computer reach such a level of intelligence that it's totally out of reach for us, and they create a new species and replace humanity. And so this is a representation of this idea. So there is no scale, but you can figure it out. So the artificial intelligence started from zero when it didn't exist, and now it's progressing, and at some point it will reach the level of human intelligence and continue, as I said. So this looks quite simple, but there are a few issues with this graph. First, we consider that intelligence can be described along one dimension. It's very linear. And also, another quite important issue is that we didn't define intelligence. Yeah. But if you consider that, human intelligence is very close to artificial intelligence. It's just a matter of how performant it is, efficient it is. So we can, with continuing on this idea, we can consider that the brain is just like a kind of hardware, and the mind is a kind of software. Okay, the picture I took is a very simple computer. Actually, this was a toy I had when I was young. It's a mechanical computer. But the principles are exactly the same than the computer now. It's just very, very simple. And it's made in plastic, and there is no electronics. But the principles are really the same. It has 3 bits. So with this comparison of a brain with hardware and mind as software, you can think that at some point you will be able to transfer your mind to a computer in the future. So many people are starting to think about this possibility, and you have a few cryonics institutes that are created where people get their body frozen when they die, in the hope that probably later on they will be able to transfer warm up their mind and transfer it to a computer. Well, there is a problem also because you're not totally sure that it will be you on the other end, but this is the reason. Okay, so now let's back to reality. So all the previous things I said are not based at all on scientific facts. But is there really a risk with artificial intelligence. So one quote I like from Yoshua Bengio, who is very famous in the domain of deep learning, is that we fight to make the machine slightly more intelligent, but they're still so stupid. And the thing I'm more worried about in the foreseeable future is not computers taking over the world, but I'm more worried about misuse of AI. And this is certainly a risk, that we give too much power to stupid machines. Now let's see what a computer understands. So these are very simple things that were mentioned in many talks previously, but I just summarize a few ideas about what machine learning and especially deep learning can be, or the different types of learning we have. Two main types actually, because there are others. So the principle is that you want to, for instance, to recognize objects. So if you want to go to supervised learning, you will tell the computer what each object is. So the object, what is an object for a computer? It's some data, some features. So it can be measures of weight, color, or things like that, or it can be a picture or a text. And then for each case, you tell what it should be recognized, like an apple, if you are trying to recognize fruit. And then through the training, you're able to recognize the case in the example set, and you're able to generalize and recognize apple you've not seen. So this works very well with, for instance, for deep learning, if you want to recognize pictures. And then you have unsupervised learning. Well, this is the same, but you don't give any label to the object to be associated with the object. You just let the computer transform the data so it's easily gathered into groups, and then you have clusters of objects, and then you can put a tag. This is banana and this is pears. But anyway, at some point you have to put a tag, because the computer can't figure out what it is. Just has data, but no meaning, semantics. So about semantics, so what is the internal representation of an object for a computer? So let's take the case of deep learning. So if you give the deep learning model a picture as input, and you want the model to recognize what's in the picture, let's consider the input data. So if you have a picture, let's say 1,000 pixel on 1,000 pixel, it's about 1 million pixel, and so then you have RGB values. So you have several millions of dimensions. So the input vector space is millions of dimensions. So that's really huge. And with deep learning, you're able to transform these data into a vector space which is with much less dimensions, let's say a few dozens, for instance. And in this space, you're able to easily gather the object or compute distances that make sense, semantic distances. So in some sense, you have a kind of semantics inside a computer. It's a kind of weak notion of semantic, but it's some semantics. But if we think more deeply about semantics in relation to what semantics is for a human being, what something means to us, actually the computer understands nothing. If we take the simplest operation, like 1 plus 1, what 1 represents for you doesn't represent nothing for a computer. Why? Because a computer is first made is first composed of hardware, so it's physical component. At some level you have physical signals, and we interpret these physical signals as zeros and ones. These are bits, or a figure like a digit, 2, if it's displayed on screen. But we really need a human to interpret the data. There is absolutely no meaning inside the computers. It's just physical signals, if you think of it. So let's see what different kinds of limitation artificial intelligence has today and might have still tomorrow. So first, with modern machine learning techniques like deep learning or reinforcement learning, it was said many times today in different talks, you need millions of examples, whereas for a human being, even a great master on a Go game, we just need like a few thousand games. So this is a technical problem, but it's very, it's a big limitation. Also, computer don't have what we call common sense. So this is an intuitive notion, but we really see that a computer is stupid because it's a knowledge which is very limited and not a general understanding of the world. And another very difficult topic, which was addressed by a previous talk, is that we're not at all able to give a computer generalization capability. So a computer is able to, with a machine learning model, to generalize from an example set, but it's in a very limited area. For instance, the great victory on Go is very impressive, but it's really limited to a very narrow domain because it's just Go. It's nothing. The computer is not able to do 1 + 1. It's just Go, which is already something. And the last thing, which is very important also, it might not be a problem with solving technical issues because. But it's a very big difference between computers and human. If you think about the fear of computer taking over the world, it's that without human interpretation, there is absolutely no intelligence in artificial intelligence. What we call artificial intelligence, it's not intelligence at all. And I added another quote here, which is from the 70s, but it's still true today. The definition of today's AI is a machine that can make a perfect chess move while the room is on fire. So this is related to common sense and generalization. And so related to this capability we have of interpreting the data, where does that come from? Why is it different for us compared to the computer? Well, it comes from the consciousness and the subjective experience we have. This is what allows us to have some meanings that things make sense. And someone who explained very well about that is John Searle, and this is related to what I said about interpreting the data. And John Searle says the program merely manipulates symbols, whereas the brain attaches meaning to them. And he explained that using what is called the Chinese room argument, which is very famous. I won't explain because I don't have time, but you can check. It's very interesting. And more generally, David Chalmers in 1994 tried to explain what was the problem if we want to explain consciousness. And he said we can distinguish between the easy problem and the hard problem. So the easy problem is how is it possible that from the perception we have, we have such a behavior. Explain the behavior based on neuroscience. So this is a domain where we make huge progress, but we're not at all able to explain how the brain works, even at the behavioral level. So we might work on that on several decades and maybe hundreds of years, but this is an easy problem. And now we have the hard problem, which is how come that we can have a subjective experience? And this is something that some people try to address, but usually when people say they try to explain consciousness, they address the easy problem. But here we arrive in a domain which is very close to philosophy, which we're in between science and philosophy. So, and the problem we have to talk about subjective experience is that we want to use science, and science work on objective objects. So one solution, which was the solution of Descartes, was to separate mind and body, so consider the physical world and the mind is something else, separate. But since then, this is not really the trend. We try to fight that usually with science. But there are different ways of explaining things. So the trend is more toward materialism and explaining things by science and physical phenomena. But then how can you study subjective experience when you need to define objective object? Well, subjective experience is actually an objective fact, but so this becomes a very difficult domain. But you have different philosophy, different types of explanation depending on your philosophy. So some deny that consciousness exists at all, and some people say that consciousness is everywhere, or some people say that everything is information. So I won't go into the detail of each of these different approaches, but I let that as a starting point. That's it.
Does anyone have any questions to Laurent? Are you sure? Okay. In that case, again, thank you, Laurent, for your talk.